To understand the concept of transfer of charge, we need to know about gold leaf electroscope. A gold leaf electroscope consists of a brass rod which passes through a rubber stopper in a glass jar. The top end of the brass rod carries a brass disc and the lower end carries two thin gold leaves, such that they hang parallel to each other. The glass jar protects the gold leaves from the outside air currents. The lower part of the glass jar in the interior is surrounded by a metal foil. When the electroscope is used, the metal foil is earthed. This increases the sensitivity of the electroscope. Some electroscopes have strips, leaves, of silver, copper, aluminium or brass instead of gold. In 1752, on a dark June afternoon in Philadelphia, USA, the 46-year-old Benjamin Franklin decided to fly a kite. With the help of his son, William, he attached his kite to a silk string, tying an iron key at the other end. Next, they tied a thin metal wire from the key and inserted the wire into a Leyden jar, a container for storing an electric charge. Finally, as the sky darkened and a thunderstorm approached, they attached a silk ribbon to the key. Holding onto the kite by the silk ribbon, Benjamin flew the kite, and once it was aloft, he went into a barn so that he would not get wet. When a storm cloud passed over Franklin's kite, the negative charges in the cloud leaked onto his kite. His kite string, his key, and the Leyden jar attached to the key by a thin metal wire. Franklin, however, was unaffected by the electric charges because he was holding a dry silk string which insulated him from the charges on the key. When Franklin reached out his knuckle to touch the key, he received a shock because the negative charges in the key were so strongly attracted to the positive charges in his body that a spark jumped from the key to his hand, Benjamin getting a shock on touching the key. Franklin's experiment successfully showed that lightning was actually static electricity. Lightning and thunder, a rapid flow of electric charges through the air between two oppositely charged clouds, seen as an intense spark of electricity in the sky, is called lightning. As soon as the negative and positive charges connect, a continuous path is formed from the cloud to the tall building or a tree on the ground. When electric charge flows between tremendously charged cloud and a tall building on the earth, we say lightning has struck in the form of a lightning strike. A lightning conductor. A lightning conductor is fixed on the top of tall buildings to protect them from damage due to lightning. Safety measures to be taken during lightning. If you are caught in a thunderstorm, you need to take safety measures. Some of them are discussed here. Outside safety measures. When you hear thunder after the lightning, rush for a safer place. An appropriate shelter could be a building or a car with closed windows. The body of car acts as a conducting path for the lightning bolt. Do not lie flat on the ground. Do not take shelter under a tree because trees provide a good conducting path for lightning. If you are in a group of people, stay about 15 feet away from each other. Stay away from all types of water bodies because water is an excellent conductor of electricity. Indoor safety measures. Avoid using electrical appliances such as televisions, air conditioners, computers, etc. Electrical lines are excellent conductors of electricity. It is advisable to unplug these electrical appliances. Do not take baths or showers during storms, as water is an excellent conductor of electricity. Lightning can strike telephone cords, electrical wires, and metal pipes. During a thunderstorm, contact with these objects should be avoided. It is safer to use mobile phones and cordless phones. Stay away from plumbing lines. Such pipes are generally made up of metal, which provide a good conducting path for the lightning bolt. Earthquakes